Hi, good morning, everybody. We're just going to give another minute or two for everyone to get connected and get their audio set up. It looks like everybody is connected with audio, so we'll go ahead and get started. Jumping right in with some announcements. First thing we'd like to let everyone know about is we're doing basically the same thing as the Particleworks tips and tricks. We're doing a similar version for the Recordine customers. I think there's at least some crossover, and I know that we've had discussions with many of our Particleworks customers about Recordine and some of the applications there. So I wanted to let everyone know about this webinar series, and it's going to be starting this month. It's going to be the last Thursday of every month, and you can register directly on our website. If you go to About Us at the top, you'll see a CAE webinars link, and then you'll see this at the very top of that page, and there's a registration button there. Next, I wanted to go over the conferences that were confirmed for this year. Probably a little bit late if anybody wanted to go, but this Thursday, so in 2 days, I'll be at the PTC User Northern Ohio conference. I'll be speaking there about one of our Recordine plugins. And we're going to have a booth at NAFEMS, that is NAFEMS Americas, I believe is the name of that conference. So that's going to be next week. And then lastly, we're going to be at PTC User, the large national conference. That's going to be in October. We'll have a booth there, and we'll be doing a presentation. If there are any other conferences that your company is going to be at and you'd like to see us there, please let us know. We don't know about all the conferences that might be relevant, so we'd love to hear where all of our customers are going to be. And then, as always, I like to do a quick refresher on how you can open support tickets. And there's the submission portal on our website, and this will automatically notify the correct person, and you'll get a follow-up link via email where you can upload larger files. You can also always email the support email address directly. This basically does the same thing. It opens a ticket, notifies the correct person. Only difference is that you don't get the cloud folder link sent to you directly. Still generated, so we can always share it with you. And then for the longtime attendees, they know that the next thing I talk about is where you can view previous recordings. So they used to be on YouTube. We've decided to move those into our ticketing system. There's a knowledge base attached there. So we were hoping to have that live before this meeting. Looks like it's going to be probably the end of the week that'll be live. So that user portal, you'll be able to sign up, log into that portal, open tickets directly there, view all of your previous tickets or open tickets. Then there's a knowledge base there. So that's something that we're working on building out, and you'll have access to all of the previous tips and tricks recordings. And they'll be sort of organized. I know with YouTube, it's all in one playlist, so it can be sometimes a little bit hard to find things. So with the knowledge base, it'll be easier for us to organize those and group them together. With that, I will pass the torch over to Chris, and he's going to talk about some of the FVM improvements.
James, I'm going to share my screen. The right one. Screen. Hey James, real quick, can you see my screen?
I can.
Okay, perfect. All right, let's get started. So today I wanted to kind of do a quick overview of some of the finite volume method, which is the FVM Solver in Particleworks. With the new major release in Particleworks, there have been some improvements on this. I won't get into every single detail today. We just won't have the time to do it, but I at least want to kind of give a brief overview, and we can talk. We can show some of the new features that have been added or have been improved for 7.2. So just a quick laundry list. Some of the features that have been improved. The FVM solver has been improved on the performance base. So with 7.2, we now are supported with multi-GPU calculations. For those that have been using 7.1, know about the multi-GPU capabilities that has been added to the FVM solver. There's been an improvement for the advection terms in the finite solver method. We can now add a pressure boundary condition, and we can add a free slip boundary condition. And then later, a little bit later this morning, James will talk about some of the steady state analysis that's available with the FVM solver. So just going through the list real quickly, this was something that we briefly touched on our last tips and tricks. I'm just going to kind of glance over it again in today's session. With the multi GPU, when we're trying to do this, by default, we have a domain decomposition that's set as default. When we're trying to do this, we need to change that in either X, Y, Z direction, and that'll help stabilize our multi GPU calculations. The other option, which I don't know that a lot of people have had a chance to really dig into this yet, but we now have 3 different options. The first one being the piezo option, which is present in version 7.0 and in 7.1. This is a transient calculation. So when you were previously working in 7.1, this was the option that was actually the only option that was available. So it was either none or piezo. Now in 7.2, we have an option called simple, and this is going to be the steady state calculation. And then we also have a simple to piezo option, which is a steady state to transient successive calculation. Those are going to be in the drop-down menu whenever you enable the FVM solver. So some of the options that are new, when we select the simple to piezo option, we can now define a maximum number of iterations. By default, that number is going to be 1,000. We can also specify the tolerance for convergence criteria. By default, that's the value given as 0.001, and that's going to be a dimensionless values. I believe those that are familiar with traditional tools, I believe that's something that we can play with as we're solving an airphase simulation. These options have now been added to Particleworks 7.2. So one of the other big change is the advection term. In the previous version 7.0 and 7.1, the only advection term that we had was what we called our upwind. The users the developers at Prometech have now introduced not only given us back the upwind, but they've also introduced a linear upwind. And so the differences between those is the upwind is going to be our first order upwind scheme, and then the linear is going to be our second order upwind scheme. And I thought about kind of putting some of the calculations in here, but there's just if I'm being honest, there's a little too much information to kind of put into these short slide presentations. So if those that are interested that are wanting to know the differences between the first order scheme and the second order scheme, you can definitely check out the FVM section in the theory manual. It does a really good job of explaining the differences and the breakdowns in the equations. I didn't put it on here, but I'll go back and edit what chapter and what section you can find this information on. When we do select the advection scheme to linear upwind, there's a couple of factors that we can manipulate now. The first one being is a blending factor. This is for our gradient term of the advection. That's given in a range of 0 to 1. 1 is going to be the default, and again, this is going to be a dimensionless factor. Looking through some of the documentation for this stuff. If we set this value equal to 0, that's going to take us back to our just upwind first order scheme. And then kind of some notes that are given in the theory manual is the more we increase this, it makes the simulations more accurate, but it also can the stability might decrease a little bit. So just kind of be careful whenever we're kind of messing with this a little bit, and just adjust it when it's needed. Another thing that's been introduced was the addition of pressure boundary. Believe in 7.1 we had the possibility of adding velocity boundary. So the way we can do that is if we're in Particleworks, and it took me a little bit to kind of figure this one out, but if we go into our miscellaneous folder, there's going to be some new options that those that are familiar with Particleworks haven't seen in previous versions. It's going to be here in the FVM boundary. When we select this, what we'll have to do is we'll have to look in the detail section, and that'll come up in our FVM boundary, and we can select either a pressure boundary or a velocity boundary. The pressure boundary is going to be a fixed boundary pressure. By default, those units are in pascals, of course. And kind of like the velocity boundary, we can actually define time varying options for both our velocity and pressure. That can be done through the keyframe option. One thing I would recommend, and as I was kind of looking through this stuff, to use the reference manual. That has some really good information. Again, kind of similar to the theory manual in the previous slides. There's quite a bit of information, not enough for me to put in the slide, but if you're interested in those, I definitely would check out the user manual for that. Another new condition that's been added is either a free slip or no slip boundary condition. We can now specify either one of these boundary conditions between the FVM grids that are generated and the polygon walls of objects inside of Particleworks. And the way to actually do this is when we bring in all of our input objects and we do set up a finite volume grid, we have to go into each of those objects found in Particleworks. This is going to be found in the details section, and there's a little bit more information. Now we have the finite slip condition. By default, that's going to be a no slip condition. And the last thing I want to leave everybody with today, there's a couple of notes that I felt like should be added here. I won't go through all these in details. Just kind of leave it up on the screen for you guys just so everybody can see. Two things I really wanted to kind of point out specifically in these notes, and this is one of these questions came up probably a year, maybe 2 years ago, I can't remember now, but somebody had asked me if we use the finite volume solver, can we use the air resistance model at the same time? And the answer to that is no, you can't use the FVM solver and the air resistance model. It's got to be one or the other. And the other thing I wanted to point out too is in Particleworks 7.2, I believe it's a beta version. I'll have to go back and double check, but we do have our LBM solver, which is our lattice Boltzmann's method. That's going to be similar to our finite volume. That can't be used simultaneously either. So it's either going to be FVM or LBM. So those are the only two things I really want to point out. Again, everything here I won't go through. You can all read them. And if you guys are interested, if you want this slide deck, let me know. I'll be glad to send that over to you. And just as James had alluded in his introduction, if you have any questions, feel free to reach out to us. We've got our support site here. With that, I'm going to pass the torch back over to James. He's going to talk a little bit more about the FVM solver.
Thanks, Chris. Let me share my screen. So as Chris had mentioned, I'm going to be talking about the new steady state solver that's available for 7.2. Really quickly. All right, so before I dive into some of the details, I want to do a level set, I guess, on what options there are for dealing with the air phase in Particleworks. So the first thing, and I wanted to label this as option 0, but turns out PowerPoint doesn't support indexing from 0. You can only do 1 or greater. So that was fun to learn. So the first option is to just ignore the air phase entirely, and that's kind of the default, but I wanted to include it for completeness. Then the next thing is specifying an airflow field. You can either do this manually or with an imported flow field from some third-party CFD tool. And when I say manually, I mean for a very simple flow field, you could type out the CSV file manually. I think I've done this in the past. If you have, I want air blowing from the right to left at 10 meters per second, something like that. You can always specify that by hand. And then next are the two FVM options, right? You can do one-way or a two-way coupling for FVM. So what I'm going to be talking about is sort of a midpoint between these two, sort of a 3.5, using the FVM steady state solver and then importing the results into an MPS simulation as a flow field. Now, why would we want to do this rather than running the co-simulation? And the simple answer is that it's slower, right? So using the FVM solver requires double precision, and depending on the hardware, this is either going to be somewhat of a slowdown or a very significant slowdown. So if you can sort of break out these phases, then your computes can be more efficient. The other kind of disadvantage to the method that Prometech uses is that you have a uniform grid size. So this is great for usability, makes things a lot simpler to set up, but the downside is always you have less control. And the grid size always has to be related to the particle size. So sometimes you want those to be at completely different length scales. And by splitting these up, you have a little bit more control. Now, this looks like a very long flow chart, but I'm just being very, very verbose in it. So in cases where you have an FVM simulation that it doesn't change much over the course of the particle simulation, what you can do is and then use it as a flow field, right? So what we do, the general overview, we run the steady state FVM solver. We then have to extract the airflow results, and this is probably the most complicated part of it, or requires a couple of additional steps. Then we duplicate the existing scene, import that airflow data, and then turn the FVM solver off, and we can solve with single precision because we're just using MPS. So how do we use the steady state solver? Chris kind of mentioned this already. We changed the solver type for the FVM solver to simple instead of the default, which is piezo. And then we assign the correct fluid material. So you'll have to have some air material phase. And then the one thing that's easy to make a mistake on is if you use ramp ups in your keyframes, then you want to make sure that whichever keyframe values you are going to be running the majority of the simulation at, you need those to be set at t equals 0, because the simple solver is only going to evaluate at t equals 0. This is sort of an example what I did when I was mocking this up. I was using one of the tutorial models, and it has you do a keyframe at 0 seconds for 0 RPM, and then it ramps up to 800. So the simplest way to make it 800 at 0 is just modify this one keyframe, and then it's running a constant value. Then we run the simulation with double precision, and we get our results, right? Now the process for extracting that airflow data isn't necessarily obvious, but the basic idea is that we're using the prof bin to ASCII tool because Particleworks is always storing all of the result data. In the case of MPS particles, that's going to be each particle has a row in the results file, and all of the properties associated with that particle are listed out in separate columns. For the FVM solver, it's very similar, but instead of each particle, it's each node or each cell in the FVM mesh. So we can use the prof bin ASCII tool to extract out that data into a human readable format. Run that tool, it'll give you an out_000.prof instead of .profbin. And there was I did a previous presentation on the prof bin to ASCII tool and kind of the format of this file if you want more details. But the key takeaway is that we want to copy that file, that out.prof file, and then change the extension to CSV, not CVS. The one thing I wanted to mention, if you make that change and then it still doesn't let you open in Excel, there's a good chance that you have file name extensions turned off in File Explorer. If you turn that back on, you might find that it's .prof or .csv.prof, and you just have to remove the .prof at the end. And then this is the details of what needs to be removed from this file to bring it into the format Particleworks expects for the airflow sampling file. Leave this up here so that in the future you can reference it. Basically what we're doing is removing these top lines, including the header line, and then removing these two columns, which we don't need, and then everything from pressure over, because all of that is not used. All we actually need for the airflow data file or airflow sampling file is a unique ID for each row, and then the position XYZ and velocity XYZ. So then we save that file, and we need to make one other file, but this one's very easy. So Particleworks, if you've used the Airflow importer before, you know that there's two files necessary. We have one file that specifies, it kind of maps each data file to a particular point in time. So you can have multiple, you can have like a transient set of results. In this case, for this example, we're just using one result for the entire simulation. You could repeat this process multiple times and have more complex behavior. It's the same basic idea. But for this example, we're just going to have 0 and then whatever the name of the file we created was. So by default, if you were following along, it would be out underscore bunch of zeros and then .csv. We then save this. So I'm saving it into the prof into ASCII folder just to keep everything in the default location. If you wanted, you could move these files around. They just have to be in the same folder. Then, basically the same as any other process. We're just going to the MIS folder, going to air, and then importing a CSV file. We select that airflow data file. This is the one from this tab or this slide. And it imports just like as if it was from an external third-party software. So this is the example from the windage tutorial. That's what I kind of mocked this up with. So if I import it, then we get a whole bunch of arrows representing that FVM steady state solution. By default, you'll probably have something that looks, you either can't see it or the arrows are very, very small. I did notice that I had to close out the scene and then reopen it for the arrows to show up. I'm not sure if that was just me or if that's something that generally happens. And then I've increased the scale on these arrows so that they're more visible. But that's kind of all there is to it. Really the only non-obvious part of this is extracting the airflow data using the prop into ASCII tool. And with that, that's all I had for today. If there's any questions, they can either go into the chat or into the Q&A section, and we'll see both of those. We got both of those up, so we'll see it either way. The other thing I wanted to kind of close on is if there are any topics that you'd like us to see covered in this tips and tricks webinar series, please let us know, and we'll add them into the list and kind of prioritize based on customer demand. Not seeing any questions in the chat or the Q&A. We'll stick around for another minute or two, but if there's no questions, then I think we can cut this a few minutes early. We do thank everybody for joining.
All right, I'm going to end it. Thank you, guys.
Thanks, Lana.